Hello, welcome to the Mark Janard Show, the cybersecurity show. OpenAI's nightmare is here because of Deepseek R1 and Raspberry Pi. In this video, I'm going to show you how Deepseek R1 and Raspberry Pi work well together. So, without further ado, let's get right into it. We're going dark. So Deepseek R1, which is an advanced AI language model, can be run locally on a Raspberry Pi using llama. Now, here's how to set it up. Prepare your Raspberry Pi, right? Use a Raspberry Pi 4B or higher with at least 4 gigabytes RAM, right? Install a 64-bit OS like Ubuntu Server or Raspberry Pi OS Lite. Now ensure your system is up to date. Peter, please put that code on the screen. Install llama. Install curl if not ready. Present. Now Peter, please put that code on the screen. So download and run the llama installer. And Peter, please put that code on the screen. Verify the installation. Peter, please put that code on the screen. Now, you're gonna wanna, you have the llama version and the run Deepseek R1. You're gonna want to download and start the model, right? Peter, please put that code on the screen. This command will automatically download the 8B version of Deepseek R1 if not already installed. Now you have to interact with the model. Once running, you can start asking questions. Use the question mark command to see available options and features. Now, the best practices for optimizing Deepseek R1 performance on a Raspberry Pi, you're gonna want to consider use the latest Raspberry Pi hardware. A Raspberry Pi 5 with at least 8 gigabytes of RAM, which is really more 16 gigabytes recommended, provides better performance for running Deepseek R1. And you're gonna want to also choose the appropriate model size. Opt for smaller optimized versions of Deepseek R1 tailored for resource-constrained devices such as the 1.5B parameter model. Then implement the model optimization techniques, right? Apply quantization to reduce model size and improve inference speed. Use pruning to remove unnecessary parameters without significant performance loss. Employ model compression techniques to decrease memory requirements. Use Docker for deployment. If you got what you came here for and you're getting value from this video, please hit that subscribe button and that like button. If you got what you came here for and you're getting value from this video, please hit that subscribe button and that like button. Thank you. So running Deepseek R1 in a Docker container can help manage dependencies and optimize resource usage. Allocate sufficient storage, right? Use a micro SD card with at least 32 gigabytes of storage to accommodate the model and any necessary dependencies. Consider external hardware acceleration, right? Pair the Raspberry Pi with external GPUs like the AMD or Intel or NVIDIA to enhance model capabilities. Explore custom hardware solutions such as those based on the RISC-V architecture for improved energy efficiency. Optimize system settings. Edit the config.yaml file to reduce model complexity and adjust parameters for better performance on the Raspberry Pi. Now fine-tune the model for specific use cases to improve efficiency. Now, here you got to manage expectations, right? Understand that while Deepseek R1 can run on Raspberry Pi, performance will be limited compared to more powerful hardware. So at first, you're going to want to expect slower processing speeds with reports of around 1.2 tokens per second for the 14B parameter model, because there are some known compatibility issues with the Raspberry Pi and the Deepseek R1. Again, the RAM requirements. It requires 10 GB of RAM, which is not supported by Raspberry Pi models with 8 GB or less. So this limits the use of larger models on most Raspberry Pi hardware. There are model size constraints. Smaller Raspberry Pi models may only be able to run reduced versions of Deepseek R1. For example, the 8B model was successfully run on a Raspberry Pi 5 with a 8 GB of RAM. Performance limitations. Even when compatible, the performance of Deepseek R1 on Raspberry Pi is significantly slower compared to more powerful hardware. That is what I have for you today. Please hit that subscribe button and the like button if you got what you came here for and you got value from this video. If you got what you came here for and you got value from this video, please hit that subscribe button and the like button. See you on the next video.